histogram. The histogram can be created for discrete and continuous. Okay. The bars, first of all, in the histogram will touch. Not like the bars in the bar graph. So it's basically another representation of data, representation of data. We will be using classes for discrete variables. They are called classes. For continuous variables, they are called intervals. Okay. So we're dividing, we will dividing the data in classes. After we divide, the width of each rectangle is the same, of course. The width of each rectangle is the same, but the height equals the frequency, or relative frequency. So let's go back to StatCrunch for a minute. I'm going to share again. So let's go to graph. This time we scroll down to histogram. Click on the histogram. We want to use the first as a frequency histogram. I'm going to choose my variable 5 again. And I'm going to compute. So what does this really tell us? It says that between 0 customers, as you see, these are classes, we are dividing the entire data set in classes. Between 0 and 2 customers, these are the occurrences. Between 2 customers and 4 customers. Between 4 and 6. Between 6 and 8. Between 8 and 10. So we are grouping the data now. And StatCrunch grouped them in 1, 2, 3, 4, 5, 6 groups. So I'm going to stop sharing for a second because I want to explain this. So in the first category, between 0 and 2, they're all equal length, right? 4, 6, 8, 10, and 12. We counted between 0 and 1, 1. So that's the level right here of 1. Between 2 and 4, not 4. So between 1 and 2, but not 2. Between 2 and 4, but not 4, 7. Between 4 and 5, but not between 4 and 6, but not 6, 11, and so on and so forth. Since we're here, let's take a look at the graphing calculator and see how we get a histogram with the graphing calculator. I hope you did not delete your data. From L1 is our data, same Wendy's customers, same 15-minute intervals, same 40 entries. We go now to, if you can get out of there, that second and stat plot. So I'm going to use statplot1, but make sure that you do not have on any other one. So I'm going to turn off statplot2. So go to 2, you don't have to because you probably don't have anything in there, so I turn it off. So I go back to statplot1. In statplot1, I have to click on to make it active. The histogram is the third in line. Not the first, not the second, the third one. The third one is the histogram. So click on it, make sure that you press enter so it's highlighted. I'm hoping that you have the list, the data in L1, and let's put the frequency as being 1. Stop right there for a moment. Since I'm using the frequency, right? See, 11 is the highest, 1 is the smallest, highest, smallest. I want the window of the graphing calculator, window, to present something like this. From 0, 11 is the highest, let's say to 12. So the x-axis should be the interval 0, 12, and the increment, let's say 2. You can put 1, you can leave 2. Now I also have to determine the window for the y-axis. I know that the highest is 11. So I only basically need between 0 and 12. So let's go to the viewing window. You can put 0 for x, let's say 12 for y, with a scale of 1 or a scale of 2, it's up to you. Y minimum 0, y maximum 12, and the scale 1 or 2. When you press graph, why am I outside? Yes, I know why I'm outside because I didn't calculate this, the amount, the sum. Okay, so I need to increase the y maximum to 20. So here's the histogram. So between 0 and 2, between 2 and 4, but not 4 and not 2, 0 and 2, 2 and 4, not 4, 4 and 6, not 6, and so on and so forth. So that's our histogram. Why would this be important to look at a histogram of the data? Towards the end of the class today, we're going to analyze shapes of data. So this does not look like a bell shape. It does not look like a uniform. They're not all the same. It does not look like a uniform data set. It looks like more of a skewed situation, more kind of skewed, pulled towards the left, a longer tail. It appears to have a longer tail on this side than on this side. So we're going to analyze those cases at the end today of the class. Okay, so our next step was complete. So we created a histogram. Now we can state the difference between bar graphs and histogram. So what is the difference then? I think I said it a couple of times, but I like anyone to emphasize what the difference is between histograms, in which we lump data sets or entries, we lump them in classes, versus bar graphs in which we don't lump them in classes. What is the difference? So difference.
Basically, the bars are touching in a histogram, and the bars are not touching.
Excellent.
In a bar graph.
Excellent. So difference between because we can't, right? So between histogram and bar graph. This one touching bars, data being lumped in classes. Data in classes. Grouped. Bar graph, not touching. Completely different categories. Different categories. Perfect, moving on. So we did create a frequency. We did not create a relative frequency histogram for the Wendy's, the customers. If you want, we can do that. If not, I would like to move on. So you want me to go back and share again? Let me know. So this was the frequency. If we want to create the same thing, so always save so you have, go under edit. I already selected save everything I do with the file, so I guess that's why it doesn't, the save button doesn't appear, save option doesn't appear here for me, but it should appear for you. So when we go to graph and then histogram, click on the histogram. This time you can change it into relative frequency. I'm using the same variable, and again you can put the x and the y axis the way you like. Name the data. You should always name the data. So again, I have customers for, I didn't mean that. I meant customers. No, not that either. Okay, and relative frequency and compute. And this time it gives us percentages, as you see. 40% for this category. So between 6 and 8, without 8, we have about 40% of the customers coming in that lunch interval. Between 4 and 6, not 6, we have about 28%. And these are lumped. The problem, and I'm going to mention this again, the problem with this is that I cannot reconstruct back the data. I cannot tell you here between 4 and 6, I'm sorry, but I don't know how many are 4, how many are 5. I cannot tell you. It says between 4 and 6, but not 6. It gives a relative frequency, which is 0.275, but I don't know how many are 4, how many are 5. That's the problem with the histogram. One other thing with the graphing calculator, I'm going to stop sharing. I want to show you one more thing with the graphing calculator. So if you'd like to go back to the plot and use what it's called trace for a second. So when you use trace, look what happens. Trace, it tells me that I have only one entry between 0 and 2. When I move to the right, it jumps to the next class and it tells me that I have 7 entries between 4 and 6, not 6. 7 entries, but I don't know how many 4s, I don't know how many 5s. Move on, it jumps, the trace jumps to the next class, and it tells me that I have n equals 11, and so on and so forth. But again, it says 16, but I don't know how many of each. I know I have total of 16. How do I create the frequency, relative frequency? This was frequency. For the relative frequency, what I did, that's why I created this table. What was this table? What was this column? The frequencies. I entered them by hand for each and every one of them. For 1 through 11, I entered the frequencies. How do I determine what one of your colleagues asked, how do I determine the relative frequency? What you do is highlight the top of the column and you just enter the label of the column where you have the frequency. I have the frequency in L3, 1, 6, 1, 4, etc. And in order to determine the percentages or the decimals if you want, all I have to do is just highlight the top and enter L3, second 3, and I divide by 40. That's what we had. And then I get all the frequencies and I can copy them. I don't have to copy them from here, I can copy them from StatCrunch because I have them. 0.025, 0.15, the next one will be 0.025, the next is 0.1, 0.175, 0.275, 0.125, 0.05, 0.025, and they better add up to 1. And once I have that, I go to stat plot. I use this, let's say we use the same plot, number 1, but this time I have list. So I had, again, I had list L3, the number of customers, and L2 and L4. We can do that. So now I want L2 and L4. Let's see what we get. Again, the viewing window is the problem. Why is the problem? Because now the height is between 0 and 3.3. 0 and 0.3. So X minimum can stay, but Y, let's say from -1 to +1 with a scale of 0.1. Here it is. Because the height is so small. Again, I can trace. And I see the first entry, 0.025, etc. So this time I created a relative frequency histogram. Stop me if you have any questions anytime, please. Okay, moving on. So finally we want to organize continuous data in tables. So these were discrete. We know how to organize qualitative. We know how to, in 2.1. In 2.2 we learned how to organize quantitative discrete. But now we want to organize continuous. Organize continuous data. First in tables. Okay, the first thing we need to mention is that this time we are going to look at intervals. So this is not an example we would work on, it's just an example to give us the idea of how we determine, let's say we have a data set and let's say it's all about age and we want to separate the individuals into 1, 2, 3, 4 different age groups between 25 and 34, between 35 and 44, and so on and so forth. So 25 is the lower limit of the first class. 35 is the lower limit of the second class. 45 is the lower limit of the next class, and so on and so forth. 34 is the upper limit of the first class, and so on and so forth. So what is the class width? So 25 lower limit for the first class, for first class, and so on and so forth. What is the width? The width of each class is the difference between two consecutive lower class limits or upper class limits, right? So between 25 and 35 I have 10, between 34 and 44 I have 10. So you can choose either one. Let's stick with a lower limit. So the width of each class, in this case, is 35 minus 25, which is 10. You can say, how do I know how many classes to create? Well, that is kind of ambiguous. Number of classes, of course, depending on how big the data is, based on the size of the data set, is between 5 and 20 classes. Okay, so here I selected another data set. This time it's continuous. How do I know it's continuous? Because I see 3.27, I see 5.78. This cannot be discrete. 5.54, 3.54. These are all entries of continuous quantitative data. So let's enter all this in StatCrunch, and we will construct a frequency and relative frequency histogram. But before that, we have to choose the number of classes. We want to choose the width of the class. We want to enter it and present it in sorted, so we can see how many classes and how we organize the data. So before we even look at a histogram or relative frequency or frequency histogram, we have to sort the data, put it in ascending order, and but not before we determine the range of the data from the smallest to the largest, select the number of classes, and see what the class width should be. Okay, so let's enter it. I'm going to share. So you can save this, and we can get out of there, and let's go to a new table, open a new document, brand new. So go to edit, go to edit, make sure that it does not give me the option to save because I already clicked on save. So make sure you save everything you worked on. And let's go to a new data table. Just click on new at StatCrunch at the top, the first drop-down menu. So go to new data table. And let's create a new data table with these entries. Again, there are 40 entries. Let's name the variable. Let's name it 5-year return or 5-year rate of return or whatever you want to name it. I already entered mine. And when you want to open the file, a file that you created before, please go to the right where it says My StatCrunch, drop down and go to My Data. So when you go to My Data, if you already created it, which I did, it gives me the data, the file. Just click on it and enter it. So please enter those 40 and let me know.